The map below shows Laura's route from home to school. When it snows, she cannot take West Street to school. How much longer is her route to school when it snows? Record your answer to the nearest tenth of a kilometer. So let's go ahead and take a look at the diagram that's given to us. We have home being at the intersection of West Street and Main Street, and school being at the intersection of West Street and Dale Drive. So when it snows, she's not allowed to take West Street, which means she must drive Main Street to Dale Drive in order to get to school. Those three streets form a right triangle, with the right angle being located at the intersection of Main Street and Dale Drive. So we're going to go ahead and use the Pythagorean theorem to help us solve for the distance that she'll take from home all the way up Main Street till she reaches Dale Drive. And then from there, we can continue on with some more steps to the problem. So let's focus on that first step of solving for Main Street. We're going to call this distance x, and we're going to actually start by identifying the legs and hypotenuse of the triangle so we know how to apply the Pythagorean theorem. So if I look at my picture, directly across from my right angle is West Street. So this 16.1 kilometers is going to be our C. And then our two adjacent sides or our legs are Dale Drive, which we'll call A, and Main Street, which is our X. So we've done the first step, which is to identify the legs and hypotenuse of the triangle. Our next step is to go ahead and plug them into the Pythagorean theorem and solve for that missing side. So we're going to end up with 10 squared plus x squared is equal to 16.1 squared. And 10 squared is 100. X squared is going to remain the same. And 16.1 squared gives us 259.21. And it does say to round to the nearest tenth, but I'm going to go ahead and do that when we get to our final answer after we take the square root. So in order to get x squared alone, we need to do some inverse operations by subtracting 100 from both sides. And we end up with x squared being equal to 159.21. And if I take the square root of both sides to get rid of that exponent, we find out that our distance on Main Street that Laura is going to walk is 12.61784451. So we have this non-terminating decimal, but we're rounding to the nearest tenth, so it doesn't really matter. And we end up with 12.6 kilometers is that distance that she'll walk on Main Street. So remember, the question isn't asking us how far will she walk on Main Street, but really how much longer is she going to have to walk all together in order to get to school when it snows. Or in this case, maybe drive kilometers. These amount of kilometers would be a long way to walk. So we have some more things to do. So we're going to go ahead and figure out, well, when it snows, what is her total distance that she drives to school? And so we're going to go ahead and add up Dale Drive and Main Street. So we'll have this 10 plus 12.6, and we end up with her distance on a snow day being 22.6 kilometers. So again, this is her snow day distance. So that's important. But we really want to know how much further is that than when it's a non-snow day. So in order to do that, we're going to just subtract the distance of West Street from the total distance of Main Street and Dale Drive. So that's that 22.6 minus 16.1. And we end up with 6.5 kilometers. So when it snows, Laura has to walk 6.5 kilometers more to get to school, or drive 6.5 kilometers more to get to school. So this problem was pretty involved. It required you to first recognize that there is a right triangle so that we could use Pythagorean theorem. Then after you needed to identify the sides and apply the Pythagorean theorem, and then take it a step further to actually add the distances together and subtract the distance of a non-snow day from the distance of the snow day. So make sure you're reading the question carefully, you know what the question is asking you, and then trying to break the problem down piece by piece so that you don't miss any important parts to solving the problem.